was that the races should be segregated. So blacks should live in one area, whites should live in another. If you did a survey, that was a common attitude that was expressed. In 70 years, and people did live in very segregated areas, so there's a huge segregation in many parts of the United States. Over 70 years, those attitudes have changed completely. So surveys in, say, 2000 found that, in fact, most people, the great majority of people, would prefer to have racially integrated communities, and only a very small minority would actually prefer to have segregated communities. But while the attitudes have changed over those 70 years, the reality of segregation hasn't changed at all. So measures of segregation are just as high as they were 70 years ago. So the question is, is why is that the case? And there's one very interesting explanation. One idea might be that there are actually racial attitudes that are kind of hidden and people don't answer the surveys the way they really feel, and they're actually acting on kind of deeper unconscious biases against people. That could be the case. But I'd like to show an example of another process that may be at work and that some social scientists have suggested may be at work that would, in fact, may be the deeper cause. So let's just do a little experiment in the same spirit of the little metal beads in the box. So let's imagine that we have two races, and I'll call them yellow and purple. And we imagine at the outset we have a wonderful, fully integrated community. So I've sprinkled the yellow and the purples onto some area where there are houses just at random. So where there's blue space, you might think there's some empty houses there that haven't been occupied. And the blues and the purples and the yellows are sprinkled over the area just at random and mixed together pretty well. Now let's ask the question, how might people move around as time goes on and they decide to move house for whatever reason? So we think of a very simple experiment to prove a point or to explore a point. Suppose that everyone would actually like to live in a racially integrated community. They're totally happy if they look around themselves and see a 50-50 kind of mix, or 60-40 mix, or 70-30 mix. Anything like that's fine. Suppose everyone in the population is like that. But let's also suppose that most people don't want to be part of an extreme minority. So if they look around themselves and see that there's only 10% of their own color and 90% of the other color, then they feel a little bit uncomfortable and they'd like to move just at random to some other place in the community. So what we'd like to do now is go through this population, check each person and see, are they living in a well-integrated community? And if so, they'll stay where they are. If they're living in a place where it's 70% the other color and 30% their own, well, they'll still stay there. They're still happy to do that. And we go around looking at each person, and if we find one person who is living in an extreme minority, then, okay, we'll take them and we'll plonk them down somewhere at random in the community. The question is, if we repeat this process, does anything interesting come out? And this is a social scientist named Thomas Schelling who did this experiment many years ago now. In fact, back when computers were in their infancy, he used to play this game at his dinner table with his son using coins of different colors and a grid. And each night they came home and did experiments on social science. So what I'd like now to do is show a simulation, which I hope will be put up on the screen momentarily. Okay. So this shows a community. Here I've got the purples and the yellows sprinkled around it randomly. The blacks are the open spaces. And now we start the rules. So the computer's going around choosing each person, seeing if they're in an extreme minority. If they are, they move at random. If they're not in an extreme minority, they leave them be. So what you find is this remarkable, very quick segregation of the community, just like kind of oil and water moving apart, all driven by nothing more than this slight tendency or preference for people not to be part of an extreme minority. So the bizarre outcome is just not wanting to be part of an extreme minority leads people to be part of very homogeneous communities. So that's not an obvious outcome. It's something that you really need to see the process happen, look at the feedbacks, probably use computation to see it come out. So that's a very interesting outcome, and this is the so-called Thomas Schelling model. Okay, so again, that shows an example of how, at a slightly higher level in our world, at the level of segregation and opinions and attitudes, where people live, how this kind of spontaneous order, this arising of organization in a system that has very small links to the actual attitudes of people, but much stronger link to the whole collective organization of the system. So now I'd like to move on to what is kind of the second half of the talk. So I've been talking about simple things in physics, first of all, that show this weird emergence of spectacular complexity you can't understand from the pieces alone. Then we moved on to social systems, some really simple ones where our behavior was constrained, such as on a bridge, we're walking back and forth. And then slightly more interesting scenario where we're looking at racial segregation and affecting the placement of people in geographical terms over lifetimes, for example, and in the United States it persists over 70 years. Now I'd like to talk about markets, which are in fact a much more complicated system, because now you have conscious human behavior involved. People are very sophisticated in the market. They don't want to lose money. They hire experts to make the decisions for them. There's big companies making very rapid, fast transactions. Is there any way you can see similar kinds of spontaneous order in the market setting? And the answer, I think, is well documented now. The answer is yes, although it's a more complicated kind of order. It's not just the obvious kind of pattern that emerges and is static, just like those rings of rocks. It's a more subtle kind of order, but it can be understood using the same kind of spirit of building up simple models and then seeing what kinds of things emerge. So I'd like to start with one kind of outstanding puzzle, and this does refer back to the power law or fat-tailed figure that was shown in the nice introduction. What I've shown here is the history of stock market volatility over, well, it's about 50 years. So what is volatility? Of course, the stock market is always going up and going down. It's very erratic. It seems like a random pattern. Sometimes, though, it goes up and down a lot more than at other times. Sometimes it's very stormy, and other times it's very calm. So volatility is a measure of the storminess. Basically, over a window of, say, a month, you average how many ups and downs there are. Is it a really erratic time, or is it a calm time? And this is a mathematical measure of volatility. So this is volatility over 50 years. And what you see is that there's lots of fluctuation, there's lots of noise, so kind of random process. But then you get lots of really big events that seem to stand out of the background as if they must demand some special explanation. And in fact, this is what economists tend to do. And the news who write about financial markets does this every day. When something big happens, they find a cause and label it with that potential cause. So each of the big peaks has been associated by economists and financial experts to some external cause. So there's the Black Monday event, which is the tallest one that you can see in the figure. There's the first Gulf War. There's the build-up to Vietnam. Each particular event is associated with one particular potential external cause. 9/11 must have caused this recent craziness in the markets. Oh, it gets crazy again. Well, what was that? Well, it must have been the beginning of the Gulf War too. This is the idea that is generally kind of taken as the base perspective in economics, that markets would be calm and in equilibrium and nothing very interesting would happen except when external stuff hits the market, causes it to do crazy things, and this is reflected in this volatility. But there's another perspective, which is that there's long been controversy over whether this is the right explanation. So in the late 80s, there was a famous paper by a number of economists, one of whom who is now Larry Summers, who's one of the key advisors to Obama. And what they did is they went back over 50 years and looked at all the biggest stock price movements, and they tried to find if there was actually plausible big news on those days that could have explained it. And in fact, they found that for almost all of those events, there was no big news on that day or before that, or just before that day, that could have plausibly explained that event. Also, they found that for many big news events that you would have thought would have moved the market in some enormous way, the market didn't really respond at all. So empirically, even though the intuition is that some big event must be caused by some big cause, some big external event must have caused that market movement, the empirical reality doesn't really back that up. It seems like markets have internal dynamics. Stuff is happening that emerges up out of the market and makes it explode up or down.